Hi, I'm JD, and what we're going to be doing today is going over three types of solutions for a system of linear equations. In this case, just with an x and with a y. You have two lines, right? And if the two lines have different slopes, eventually they intersect, right? And they're going to intersect at a point. See that? At a point. I know it's three-dimensional and they're more like planes, but just bear with me. And so number two, you have parallel lines, right? The parallel lines never intersect. And for the last case, you have the same line, right? Just probably in disguise. And if that same line, you're going to have infinitely many solutions. So let's go over it real quick. And I'm going to go over the types of solutions. What are you going to get? The is it inconsistent, consistent, or dependent or independent? And then also, if you're doing substitution or elimination, what are you going to find? And that's probably the one that you most want. Here, it's very straightforward. There's going to be a solution, and since they intersect at a point is your solution. And this is what's called consistent and independence. Now, when you're doing a system of equations, substitution or elimination, what you're going to get is something like x equals 3 or y equals 2. And so that's what you're going to get. You're going to get something like that. X equals some number or y equals some number. Now over here, number 2, they have different y-intercepts and they have the same slopes. They're running parallel to each other. And so in this case, in a xy plane, they're never going to intersect. And so there's no solution. And that's what's called inconsistent and independence. And so what you're going to get when you do substitution or elimination method, your x's and y's are going to cancel out. And you're going to get something like this. 0 equals 1. 2 equals 3. And you're asking yourself, doesn't make any sense. Well, that's because it's always false. There's going to be no solution. 3, you're going to have infinitely, I'm going to abbreviate here, infinitely many solutions. And the reason for that is if you imagine a line on top of another line, and you're looking for the overlap. You're looking for, okay, where do those two meet? And they always meet, right? As long as they're on the same line, and you have all those points. Those are your solution. So your solution is simply the line itself. And that's what's going to be called consistent. And that's going to be dependent. Now, in those cases, when it's like that, when you do substitution or elimination, both the x and the y is going to cancel out, and then you get something like this. 0 equals 0, or 5 equals 5. You're going to get it where a number equals the same number, and you're like, that makes sense. Well, what that means is you can plug in any x in any y, as long as it falls on the graph, and you'll get a true statement, always. So, infinitely many solutions. And that's it.